if a particle is moving around the circle at a speed of pi over 3 radians per second, then it's going to take 6 seconds to get all the way around, right? 1 second to get to pi over 3, 2 seconds to get to 2 pi over 3, 3 seconds to get to 3 pi over 3, right? There are 6 of these slices, these pi over 3 slices in a circle, and we're basically covering one of those slices every second, so it takes a total of 6 seconds. Now, if we were to do this using a formula, we would take our distance, 2 pi radians, divided by our speed, pi over 3 radians per second, and that will simplify to 6 seconds. So similarly, if we're going at pi over 6 radians per second, well, it's going to take us 12 seconds because we have 12 of these slices between 0 and 2 pi, and we're traveling a slice every second. But again, in a formula, it would be our distance, 2 pi, divided by our speed, which is pi over 6, which again would, if we were to copy, switch, flip, actually do this fraction division, we would get 12 seconds. Okay. Last, this one's a little bit harder to picture, 4 radians per second, but think about what we've done in these last two. We've taken our distance of 2 pi and divided it by our speed. So in this one, we're just going to do the same thing. We'll say 2 pi is our distance divided by our speed of 4 radians per second, which tells us it's going to take us pi divided by 2 seconds to get all the way around the circle. Now think about this for a second. If there are 2 pi radians in a circle, I'm not sure why I drew the axes there, but there's 2 pi radians in a circle. 2 pi is about 6.28, so 6.28 radians, which means 4 radians is going to get us almost all the way around, right? It should take us longer than 1 second since we're traveling 4 radians per second, and there's 6.28-ish radians in a circle. And it turns out pi over 2 is a little bit more than 1, right? It's 3.14-ish divided by 2, which is going to end up being a little bit more than 1 second. And so that makes sense visually as well.